Take a look at this. Drones painting in the night sky. How do all those drones fly in sync with each other to create the three-dimensional image of a dragon flying through the air? Clearly, there are not hundreds of pilots each flying one of the drones. More likely, each drone is flying a pre-programmed flight path after all being launched at the same time. After your students have completed the Code Your Drone activity in Mission 5, they will have the basic skills needed to code multiple drones to fly in synchronized patterns. In this video, we're going to show an extension activity for Mission 5 that you and your students can use to open the door to all sorts of pattern flying possibilities. To get started, ask students to imagine a flight pattern that several drones might do together. Help them come up with something that would be interesting to code, but simple enough to accomplish during the class. For this video, we've chosen an example of creating a wave pattern, but feel free to come up with your own ideas and let students experiment. To plan this motion, we can ask students to simply hold the drones while turned off and to model the motion they would like to achieve. We'll then have a discussion about what each drone would need to be doing to accomplish the pattern. This discussion is really important because it's when the students are learning to clearly communicate how to accomplish their goals. So after discussing our wave pattern, we realized that we need each drone to move up and down in space. We can code that by using blocks for when clicked, take off, and land. So that will get one drone in the motion we want, but if all the drones execute this code at the same time, it won't be a wave, they'll just take off and land at the same time. We need each drone to launch a little bit after the previous drone, so their motions are staggered. So let's program a delay or a wait time that is longer and longer for each drone in the sequence. Here we can add a block for wait 0.4 seconds to the second drone in the sequence, and then each additional drone gets 0.4 seconds more wait time than the previous one. And then we all press run code at the same time. Now we have our wave. And how do you think changing the length of the wait time would change how the wave looks? Or what if we wanted the wave to repeat over and over again? The learning value in this activity is really in taking the idea or visualization of what you want the drones to do and translating that to the code. The tricks and fancy movements are just a matter of how much time you want to invest in the cool factor. But we're trying to show students that they can picture something, dissect it, and code it, and make it happen. You can try this process of modeling, discussing, coding, and flying with other patterns as well. Even two drones can lead to interesting discussions, like how can you create a leapfrog pattern? Your students will dream up an endless variety of synchronized flight patterns as wide as their imagination. If they can imagine it, they can probably fly it.